Now we are going to start with scalar and array operations on vectors and matrices. Numerical operations can be done on entire vectors or matrices. Let us say we want to multiply every element of some vector, say v, having values as 3, 7, 2 and 1, and we want to multiply this vector with some value, let us say 3. We get a resultant as v1 equals to v into 3. So this will multiply the number 3 with every element of vector v. Similarly, if you want to divide every element of vector v with some value, say let us say 2, then we got the resultant as, we are using command as v by 2, and this will gives you the resultant as 1.5, 3.5, 1 and 0.5. To multiply every element in a matrix, let us take some matrix mat equals to 4 to 6. We are taking values 4 to 6 in first row, and 3 to -1 to 1 in second row. So this will gives you the matrix as 4, 5, 6 and 3 to 1. Now we want to multiply every element in a matrix by 2. So we are using command as mat1 equals to mat into 2. So this operation is referred to as a scalar multiplication. We are multiplying every element in a vector or matrix by a scalar. So array operations are operations that are performed on vectors or matrices term by term or element by element. This means that the two arrays must be the same size to begin with. Let us take an example as, let us take variables, no, we are not giving name as v, we are giving a equals to 2 to 5. So this is a vector, and similarly b equals to having some values 33, 11, 5 and 1. So now we want to add these two vectors, a plus b. So this gives the summation of the two vectors. Let us take one more example. Matrix equals to 5 to 8 semicolon 9 -2 3. So this is a matrix A, and matrix B equals to reshape 1 to 8, 2, 4. So this gives you the matrix B. Now we want to find the difference between two matrices, mat A minus mat B. So this gives you the resultant as shown here. However, for any operation that is based on multiplication, a dot must be placed in front of the operator for array operations. For example, let us take a vector v equals to the same vector 3, 7, 2, 1. Now, if you want to find the square of this matrix and you are using command as v raised to power 2, this will displays you the error, that is input must be a scalar or a square matrix. So instead of using direct the power sign, you have to use v dot power 2. So this is how you can calculate the square of each element of the vector. Similarly, the operator dot star must be used for array multiplication and dot division sign or hash sign for array division. Like I'm using, we have a matrices as 2 to 5, b equals to same 33, 11, 5 and 1. We want to multiply these two matrices, or we can say vectors. We are using the command as a dot star b, or if you want to find the array division, we are using the same mat A and mat B matrices. This is mat A matrix we are using earlier and matrix B. So we are going to find the array division of these two matrices by using mat A dot dash mat B. So this is how you can find the array division of a matrix. So here these operators are called the array operators and are used when multiplying or dividing vectors or matrices of the same size term by term. So matrix multiplication is a very different operation and will be covered further on. Let us take a matrix A equals to 3 space 8 space 0. This is our first row. Second row is 1, 2 and 5. Matrix B equals to 1 space 2 space 3 space 1. This is our first row. 4 space 5 space 1 space 2. This is second row. And our third row is 0, 2, 3, 0. So this is our matrix B. Now we want to calculate the matrix multiplication. C equals to A star B. So this will gives you the resultant as C equals to having some values. Now in MATLAB, these operations are accomplished using star operator, which is the matrix multiplication operator. The first column vector C and row vector R are created. Let us creating two vectors C and R. C equals to 5, 3, 7, 1. R equals to, this is a column matrix or vector we can say. Now I am creating a row vector as R equals to 6, 2, 3, 4. So this is the row vector. Now we are going to multiply by using star sign R star C. This will gives you the resultant as 61. And if I am using C star R, this will gives you a matrix multiplication. there are also operations specific to vectors like dot product and cross product. Let us take some examples. We have vector 1 as 4, 2, 5, vector 2 as 3, 6, 1, 2, then vector 1 star vector 2 dash. So this is what I have done is, I have mistakenly taken the vector 1 as 3 columns, but we have to choose 4 columns because vector 2 also have the both vectors should have the same size. So I'm just again writing the command as multiply vector 2 dash. So this will gives you the multiplication, and we want to find the dot product. We are using the command as dot vector 1 comma vector 2. So this will gives you the same result. If you want to find the dot product, you can directly write a command dot, then in parenthesis write vector 1 comma vector 2. This will gives you the dot product of the matrix. Similarly, if you want to find the cross product, you can write it as cross vector 1 comma vector, so it's vector 2. This will gives you the, what I have done is, then again I have chosen the wrong vectors. Vector 1 equals to 4, 2, 5, vector 2 equals to 3, 6, 1. Now cross vector 1 comma it's vector 2. So this will gives you the cross product of the matrix. So this is all for today. Thanks.